Hi everybody, welcome back. This is AP Chemistry, Chapter 5, Lesson 2. I think it's our second video, I hope. Maybe our third? It's our second video, so Joanna says, and she knows everything. Just ask Christian. What we're doing in this, I just want to walk through one problem today, and it is related to the problem, like example number 7 that you did in class today, which basically is stoichiometry just with gases. So just like we have with solutions and then we had molarity as a new way to find moles, well now we have gases and we can find moles and then pressure or volume. We have Pivnert now. So we just have another equation to tie into this whole mix of, if you know one thing in the equation, you can find everybody else, right? So this one's different than number 7 because in number 7 they actually gave you the equation and it was already balanced. Here they did everything in words. So the first thing you have to do is write and balance the equation, and then we can plug in the information underneath it. So we have methane gas that has a volume of 2.8 liters at 25 degrees Celsius and 1.65 atmospheres. We're mixing it with oxygen gas, which has a volume and a temperature and a pressure. And then we ignite it, and it makes carbon dioxide and water. And they want the volume of carbon dioxide formed, and they give you the pressure and temperature of that. So the first thing you want to do is write and balance the equation. We are mixing methane. Methane, remember, is CH4. We're reacting that with oxygen. Oh, it's combustion, right? We get a little spark to activate that reaction, and we make CO2 and H2O. We have to balance the equation, 1 carbon, 1 carbon. We need 4 hydrogens, so we'll put a 2 there. And we have 4 oxygens, so we need a 2 here. Okay, so now our equation is balanced and written. We have methane gas, which is at 2.80 liters. It's at 298 Kelvin and 1.65 atmospheres. We have oxygen gas, which is at 35 liters. So what is that, 304? Kelvin and 1.25 atmospheres. We ignite it, we make carbon dioxide and water. They want to know the volume of this if the pressure is 2.50 atmospheres and the temperature is 125 Celsius. So that's what, 398 Kelvin. Okay? Shh. Do you hear it? There should be bells and whistles going off in your head right now because you are given amounts of 2 reactants. And whenever you are given amounts of 2 reactants, it is a limiting reagent problem. So we have to first get these in moles so that we can do our limiting reagent problem, right? We are given amounts of both reactants. So let's get moles of each one, and then we can figure out who's limiting. Now, you have V, T, and P. You should be thinking Pivnert, because now we can find moles of each one of these using Pivnert, okay? So we'll do that next. I'm just going to go to another screen here, and I'll keep. There we go. Okay. So if we take our CH4, we do the moles of it first. I like to rearrange before I plug in. So I'm solving for moles, so I'm going to have PV divided by RT, because then I only have to touch my calculator once. Our pressure is 1.65. Our volume is 2.80. This is of the methane. Our R is 0.08206. And our temperature is 298. So we can solve for the moles of methane in that manner, right? And I got for the moles 0.189. That's our moles of CH4 that we have. Okay, now I need to find the moles of oxygen that I have, so I'm going to do Pivnert with oxygen. And again, we're solving for moles, so I'll just rearrange the equation so I have N by itself. It's PV over RT. Our pressure of oxygen was 1.25. Our volume is 35. Wow, we have a big volume of oxygen. Our R is 0.08206, and our T is 398. Or, I'm sorry, 304. Is that the right T? Okay. So we'll solve for our moles this way. So what you get for your moles are 1.75 moles of oxygen that we have. So now we have moles of each reactant. We do a mole-mole between our reactants to find out who's limiting. So I always remember start with my first guy, which was the CH4. Oh man, sorry. We have 0.189 moles of the CH4, right? So we have 0.189 moles of the CH4. So according to the equation, for every 1 mole of CH4, I will need 2 moles of oxygen. So that means if I take 0.189 and multiply it by 2, I get 0.378 moles of oxygen needed. If you compare what we need to what we have of the oxygen, we have more than enough. So oxygen is not your limiting reagent. This is in excess. This is your limiting reagent. It will run out first. And now we can go ahead and do our typical, if we know the moles of the limiting reagent, we can find the moles of the product that they ask us about. So now we'll do a mole-mole between our limiting reagent and our product, which was the CO2. And what's nice is they're in a 1-to-1 relationship here, right? For every 1 mole of CH4 that you react, you'll generate 1 mole of CO2. So that gives us, God bless you, 0.18. Jessica's sneeze got me all confused. That gives me 0.189 moles of CO2 that we're going to generate. Now we have the N, we have the P, we have the T. We can solve for volume. Just using Pivnert now, solving for volume, right? So of our CO2, PV equals nRT. Yes, this is our third Pivnert calculation in this question. This time, though, we're solving for volume. Volume equals nRT over P, right? So our moles are 0.189. The R is 0.08206. I forgot the temperature. We gotta go back up. The temperature is 398. And I think the pressure was 2.5. Let me just go back up and check. Yep, 2.5. So notice too, one of my little tricks is I wrote the given pressure and temperature and volume under the thing that they were given. Otherwise, there's just numbers floating everywhere. So I wrote carbon dioxide's pressure under carbon dioxide in the equation, and the temperature of carbon dioxide under carbon dioxide in the equation. It helps to keep you organized. So then we'll just do our math and solve for our volume of carbon dioxide. Easy peasy. And you should get 2.47 liters. Okay? There's no way, the only way to check it would be to go back and do anything else. There's no way to logically think about it. But I wanted to show you how not only can they do a simple problem like they did with number 7 in your notes, right, where you were given grams of the calcium carbonate and you had to find the volume of CO2 or the moles. They could also do it this way, where they give you enough information to find moles of your reactants. It's a limiting reagent problem, and then you do always what you've done. So Pivnert just adds another dimension, where now if we have pressure, volume, and temperature of a gas, we can find moles of a gas. And if you know the moles of one thing in the equation, you know the moles of anything else. Have a great night, everybody. We'll be doing practice with this tomorrow. We'll see you. Bye-bye.